Hello everyone. If you remember, I have presented my first model about 2 weeks ago, and last time I received 75% prediction accuracy. And it's been about 2 weeks, so I decided to do a version 2 because I'm not satisfied with the accuracy. So in version 2, I made some corrections and modifications to achieve a higher accuracy. As you can see, the result is very promising. I improved my prediction accuracy from 75% to 77%. And my rank in the Kaggle competition, my previous one was 13,000, right? That's my rank. And now my rank is 9,600. Okay, that's a big improvement. So what I did to improve the accuracy, I didn't change the model, the logistics regression. I didn't change that. I'm just making sure I did a better job. I do a better job in terms of cleaning and organizing the data. For example, the age column, now I fill the NA values with the average age. Before, what I did was I delete those rows, which remove certain information from what was given to me. Okay, so that's a big change. Another thing is I believe it's best to scale the labeled data and unlabeled data together. In this way, we have the same scale. The other thing is sometimes in our last step we need to do the prediction, right? So if I don't do the scaling and the transforming data together with the label data, and it will become redundant steps. You have multiple steps you have to repeat to deal with the test data. Okay, so that's good. The next step I want to do is I will probably separate the video into 3 sessions, 3 processes, and the first one is going to be exploratory data analysis, where I clean the data, fill the NA values, change the categorical data to numeric data. So that will be one portion, and this time I decide to do it line by line, so it's going to be very clear for everyone how I did the coding. Okay, thank you. Okay, let's get to the coding. First of all, let's import some libraries. Import numpy as mp, import pandas as pd, import matplotlib.pyplot as plt, import sklearn. That's a machine learning library. Okay, import that. Next thing I want to do is to load the data. Okay, load the data, read the Excel. Before I go through this, let me show you the Excel I'm talking about. You can see here, that's the data that was given to me, the passenger survived and all that, right? And also you can see here, so everything that has a survived data, that was what's given to me. And then what I need to predict is from passenger 892 to 1309. Okay, so I combine those two things together in Excel, and then I added a column called a category to say what are the data that's being labeled and what are the unlabeled data. You can see here very clearly the labeled and unlabeled. So I did it in Excel. It's saved as a data total version 2, which you can easily do. And again, as I said, the purpose of this is you can scale the data all together, when the training data and test data all together. So save this again. So now we need to load this data into Python. Okay, I load it, and then let's quickly check. Type data, you can see here have labeled and unlabeled, total 13 column, 1309 lines. Okay, the first thing usually after I load the data is to check if we have duplicates. Okay, go here and then add a line column. How do we check the duplicates? Data dot duplicated dot sum. We don't have duplicates, which is good. The next step I want to do is, do we have any missing values? How do we do this? You can basically use the data info, okay, to check. As you can see here, the survived has some non-null values, which we know because we've put everything together. You know, even the data that to be predicted, so that's empty values. That's understandable. And see age, we have non-null value of 1000. That means we're missing 3000 age values, right? And we have fair, we have only missed one of them. Cabin information, we have only 295 values and we're missing 1000 data. Embarked, we're only missing 2 compared to 1307 compared to 1309. Okay, that's the missing value. The next thing you want to do is to deal with those missing value. Okay, what I want to do now is we start with the small one. Let's say we have data dot fair dot is null. Run it. Fair. Sorry, my typo. It should be F. Okay, you have to type exactly. So you can see the fair column. There's one missing value, but it's in the category of unlabeled. That means that passenger information I cannot just delete it. If I delete it, I won't be able to make a prediction. So that one I have to keep it. Next thing I want to check, what about the embarked? We have 2 missing values, remember? So data dot embarked is null. Check the column, check if it's null. See, we have two rows, label data, missing embark information. So to make it simple, we can just remove that. So as I can see here, the drop rows that has null value in the labeled data, we can say data now is equal to data dot drop NA. Use this function. Subset drop NA subset equals to embarked. Okay, so now after we drop 2 lines, let's do this, or maybe we can do data shape. See, now it's only 1307 lines. We delete the embarked. Okay, wonderful. Now let's the big change I want to do in this version 2 is the fill NA value with the age average and also the fair. So those are the 2 things I want to keep them. Okay, so how do we do this? We can say data age equals to data age. Use this, so this column I want to fill NA with what information? With the average age. mean. Okay, so we do this step. So there's some warnings. We are fine with that, no worries. And then the next step is we will fill the NA, not only the age column but also the fair. Okay, so I just need to change that. Fair. Okay, change the fair. Okay, wonderful, we did that. Now the next step we're going to do, check again. Data is null, sum. So now you can see survived. We know that we have null values, which is good. We keep them. Sex is now filled with NAs. Sex with is now no, age is now filled with the the average age. Fair, we have that information too. Embarked, the reason why it's 0 because we delete those two rows. Okay, now the only thing we need to deal with is the cabin. The cabin has so many missing information, so much missing information. So what I decide, we can just delete that column, drop it entirely. How do we do this? We can use a method called data drop. Okay, and then we go from here. We say cabin, make sure C is capitalized, and then make sure you also enter the axis so that it knows we are dropping a column. Okay, in place is true. Okay, now we drop it. After we drop it, let's do the data shape again. Let's say sorry, there's supposed to be no bracket. So 1307, now it's 12 column because we just dropped the one column. Okay, now next thing I want to do is, because the machine learning like to have the numeric data, we have to change categorical data to numeric. There are many ways to change category data to numeric, but I have researched in the internet. I find this method is quite simple. Let's create kind of dictionary. Let's say cleanup column equals to the big bracket, right? It's a dictionary. So now sex, in that sex column we have male and female. Let's put a quotation mark here. Male, let's make male 1 and female 2. Okay, so that is this column. What I'm trying to say is, in this column, like the sex column, whenever there is a male, we change it to 1, female change it to 2. This is like, if we can do this in Excel, to say, use a VLOOKUP function to replace those values. But while we are here in Python, let's do it in a Python way. Okay, so here we change that. We also want to change the embarked. Embarked has 3 categories. Okay, have a little dictionary inside it. S is now 1. C is now 2. Q is now 3. Okay, then we have big bracket. S1, C2, Q3. I think that's everything, right? We have the cleanup column. Unmatched. I think we are missing some values here. We have the male, we have the female. Yeah, this one is too much here. Change that. Okay, so we did this one. Now what we do is we can use a method called now let's change the data, transform the data to df. Okay, a new data frame called replace data, replace cleanup col. Okay, so let's do this. So after we do this, you can see the df, the new data frame which we just created, look like this. See that? Oh, well, still sex has not been changed. Now I know. Now I know, because in the sex, the male and the female are this. Sorry, let's change this. You see the small case, and then I need to redo this. Do this. Now the sex, 1 and 2. 2 is female, 1 is male. Embark towards 1, 2, 3 now. Okay, so we have a perfect data frame right now. Okay, the other thing we need to realize that passenger information, right? It's useless for us, 1 to 1300. Ticket number, I don't think they are quite useful. I'm gonna remove that. And what I mean is not useful is, it's not useful for us to use that information to predict survival or not. And the name, not really very helpful. Okay, so I want to delete those 3 columns. How do we delete that? We can use a function called drop again. So now it's data frame, the drop. What are the columns? Passenger, ID, drop this column, and then we drop this column, name, and ticket. So we are dropping this, but also we need to tell Python that we need to drop the column in place equal to true. Okay, drop those 3 columns. Axis drop, get multiple values for argument axis. Why is this? df dot, I see, we need, this is where we're dropping 3 columns, so we need to have this. We need to have a square bracket to cover all the column names. Now we are good. You can see after this we have define info, we have category survive, those are the category and y, and then we have p class, sex, age, siblings, parents, fair, and embarked. Okay, so now after all the deletings and everything, the index need to be changed. That's why it's going to be very useful in the future, because right now if you should check the index, it may be not sequential anymore. Okay, so how do we do the reindex? Let's do df. There's a function called method called reset index, and when we say drop equals to true, means we are dropping the old index. Let's do that. So we just did it. Now let's check. So you can see we have 1307 rows. The index is from 0 to 1306. Now that we know, we no longer have gaps before. No longer have gaps in the index. Okay, great. Let's have a short break. Let's do the analysis after the clean. This is considered that we have cleaned up the data, basically removed unnecessary columns and removed unuseful rows, and now it's become the data that we can analyze. Okay, so we did the data preparation. The next step is to do some analysis on the y and x axis, try to understand relationships. Okay, let's analyze the data y, which is survival or not. Okay, so as you remember that we have two sets of data. One is labeled, another one is unlabeled. We will now only analyze the labeled data. And okay, so we will separate the data frame into data frame underscore L, means labeled df. Whenever df in that data frame, we have whenever the category is equal to labeled. Okay, so that will become our dfl, and then we have df underscore ul unlabeled equals to, okay, let's copy that. So now we have two data frames. Okay, whenever it's unlabeled, let's call it dful. Okay, just so that we see dfl looks like this. So you see it's from index 1 to 888. Then we have df underscore ul. Right, it's everything is unlabeled. You can see it's 418 lines that we need to predict. First of all, let's see if the data is balanced or not. We would always like to have a balanced data. When I say balanced, means, for example, you give me a data set and you say out of the 800 people, let's say 700 died and 100 survived. That will be considered unbalanced data, which is, if you learn the theory and the algorithm behind it, you will know the unbalanced data is not good. Okay, let's check. Let's visually, we use Seaborn. Let's do a count plot. In the x-axis, let's use the survived, okay, as x-axis, and then the data we will use is df underscore l. Okay, this is a count plot. As you can see here, let me remove this guy. As you can see, we have about 300 people survived and 500 people died. So I would think this is a good check to say our data is not that unbalanced. Okay, next thing I want to do is to do a chart like this to say for the survived and unsurvived, does age play a big role here? Okay, we can do a box plot. Why do we do box plot? Because age is a continuous, it's a numeric value, it has a distribution, so we can do the box plot. Again, the x-axis is survived, y would be age, and data equal to df/l. Okay, so it will give me the column exactly like that. So we can see, from the box plot, the median age is around 30 years, but you can see, based on the range, we have many outliers here, right? So from 50 years old above, many people died. But in the survived category, we have people, 60 years, but nothing from here. in this range from 60 to that. So a little bit different distribution, but median wise, I think we are very close. But also we can see even the young age people more likely to survive. You can see this line is a little bit under this, and the box is also wider in this range. So that's the idea, but age has some relationship with the survival or not. Next thing we want to do, let's check if the fair impact the survival or not. So this time we do the X as survive, but this time we'll do Y as fair. So if we do that, you can see if people pay more, generally speaking, they will highly likely to survive. Okay, then so those are the two things. That's numeric data. Now let's do something about the categorical data. So for the categorical data, we will not do the box plot. Instead, we will do the count plot, which is more. Okay, let's do the count plot. Okay, follow the same principle. Let's do the X. Now the count plot. Let's compare this now. Let's make X is P class. Okay, P class, and then hue equals to survived or not. Survived, and then again we need to specify what data frame we're talking about. Yes, we're talking about the label data. We're only analyzing that. Okay, so if we do this, you can clearly see in P class 1, more people survived than died. But in P class 3, more people died than survived. So there is a relationship between the P class. It's very clear, right? The higher, the top of the class, the higher the chance you will survive. Let's do the same thing for the other one, and this time I believe we can do one for the sex. X is sex. Okay, according to this, we can see in the females, out of all the females, more survived than died. Okay, if you are a man, then you die, then more people died than survived. I believe that's a good thing. Maybe men give opportunity for women to survive. Well, that's good. Okay, and now let's do the embarked. Embarked is basically where people are boarding, like when they first on board the Titanic. Okay, so this one, we'll change this to embarked. Okay, you can see if people embarked in the second place, they have a little bit more chance to, survive. Okay, then let's talk about the siblings and parents. Here we do a SIB. SP. Not very clear, but if the thing here is if you have no siblings, you have a higher chance of dying, less chance of surviving. For all the people who don't have sibling, more people died than survived. Okay, then let's do the parents and child. Peach. I do the same thing here. Okay, so you have parents or you have children. I think right, it's very close to that. If you have like no parents or no children, you're just a single, more people died than survived. Okay. Now so we did the analysis on the y's and x's, right? The relationship between the x and y's. We can now start to do some analysis. Is there any relationship between the x's? Okay, so we use a very common method called the correlation. Okay, let's call this. Let's define a variable equal slash CORR equal to df slash underscore, right? CORR. That's correlation. Okay, so that's the correlation. First of all, correlation between the x's and y's, and then we just see it from here. VORR CORR. VAR. Okay, so we see the numbers. Negative means negative relationship, positive means positive relationship, 1 means just a linear line. That's a strong relationship, positive, which is understandable. Then if we want to see it visually, we can do SNS heat map VARR VARCORR, and then we need to put this guy in. A note means we will note it. Or else if we don't do this, it will show only the colors, you won't see the numbers. Okay, so now we do it like this. So take photos. As you can see, there are some strong colors. For example, 0.55. Let's take a look at the survived. Who has relationship with the survivor? You see the sex, 0.54 is kind of a strong relationship. Usually when we say if the relationship is like 0.8 or above, that's very, very strong relationship. But I believe comparing others, 0.54 is already considered a quite strong relationship. And the P class, see, P class 0.34 means, when the P class increases, the survival rate goes down. Means if you have a P class of 1, you have more chance of survival. And this is basically here. You can see if you're P class 1, you have more chance of survival. If your sex is 2 females, you have more chance of survival. So this basically testified again by using this map to telling us what are the relationship between the x and the y's. Okay, so this concludes the exploratory data analysis. Now we're almost getting ready for the modeling. Okay, let's take a short break and we will start again.